Okay, let us get started. So let me share the screen. This is the stop one. Okay. Can you see my screen now?
Yes.
Yeah. So yeah, we'll just revise what we did in last class, and then we'll start with a basic programming constructs. And yeah, we'll make use of our AI assisted tool, and then we can generate the programs and understand how it works. So you don't need to remember anything, but you need to understand how things work. And yeah, so for any given programming language, right? So these are the basic things that uh, any language has. So I'll just give you an idea from yesterday's class. So we learned that there are um, ways to put the program onto your destination machine, which is generally your laptop. Like you write the program and then you execute it. And how does that execution happen? So we saw a little bit in yesterday's class. I'll just show you, regardless of which language it is. I'll just show you on the command line like how it works. Okay. So I have a let us take, for example, a C programming language. So we are going towards language agnostic. So in the sense that if you are able to understand, like recognize variables, functions, files, and modules, importing, and all these things. So if you can do it in one language, you can easily look at similar patterns in all of the languages. So we will go to Python. So before that, I'll show you something in C. This is important because you'll have a journey that how does a program get converted to an executable, and what are the ways. So thereby I want to establish a concept called as compiled languages and interpreted languages. So C is an compiled language. I'll show you what it means. So don't worry about the commands. So I'll just open the program sum.c. It's a C program. So what it does is quite simple. If you look at, yeah, if you're looking at the program for the first time, it looks like gibberish, but I'll just explain what it is. Okay, where is my... For any given language, we have variables and there are data types. So I'll just tell you what it is. So now you can see that I have opened in VI editor. It does not have, it is just like normal notepad. If you open any text file, it does not have any syntax highlight and all these things. But there are some modules which you can load into the VI editor where it can highlight the syntax, but by default it does not have anything. So what you're seeing here is a C program, and you can see this particular construct. So this is called as headers. So this is common in most of the languages. So, and then this is called as function, and you can recognize it in a while. So it says that this function name is called as sum, and it has some braces here, and then it takes some, it has, it takes inputs, and it does something which is like summing up number and returns that value. And there is a function called as main. This main function is the one which tells the the CPU that this is where you have to, this is the starting point. So yesterday we saw a program like how it gets into the computer, right? So you have RAM, you have CPU, which is a chip, and then we write the program on your laptop or wherever. So we have the hard disk. So when we do save, that is like Control S, your file gets saved. So in this case, it is sum.c. Sorry, .c, sum.c, and we are going to compile and we're going to load it into the RAM, and then it gets into the CPU. So we'll just see how it works. So of course we cannot see what is inside the happening inside the CPU, but this is how the process works. So so all the programming constructs. So yesterday we also saw that CPU does not care what language. It does not. It is not aware at all. So it just takes the signals, right? Ones on which we call as ones and zeros, stream of ones and zeros. And the pins that you have in this CPU, like if you open any like motherboard, so each of the CPU has uh, there are hardware pins. So these are the pins where the signals get into that. So so in a rough way or in a vague way, if you want to talk, so if it has 32 pins, like 1, 2, 3, 4, and then 16 here, 16 here, it's a 32-bit machine. So if it has like 64 pins, it is a 64-bit machine. Okay. So this is like very vague, but yeah. This is if you have seen engineering students buying a small chip, which is probably 8-bit or 16-bit chips, and they would do some experiments. So that is like 16-bit chip and so on. So that is why this is important is when you compile a program or when you load the program, you forget about the program that we have written. So even if you write it in assembly language, and then that assembly language needs to be translated to something called as object code, which is nothing but streams of ones and zeros, and then that is loaded to given to CPU. So any program on any given day, so goes through these processes, which is you write a program in whichever language you do. Why the languages are invented is because yesterday we were saying, so you cannot remember the streams of ones and zeros. And to automate this, so people came up with assembly level languages, and then you cannot remember all the chips all the chips data set. For example, there is Intel chip and then there is AMD chip and so many chips, right? So you cannot remember all of these instructions. So you want to so people invented languages which are independent of these chips. So that is how there is an abstraction. So ones and zeros is automated by assembly languages. Assembly languages are automated using higher level languages, and then there are from here there are like sophisticated languages which are closer to human languages, which is natural language processing. So if you think about it, today's programming language, as we discussed yesterday, is not any C, C++, Java, or Python or anything. It is English. This is the reason anybody can program and you can do this process. So if you look at this process closely, let me take. So we were now getting back to the program. So we have what context, what we are trying to do. So if you look at this particular thing, there are some statements called as print and scan. So print is nothing but it prints something on the screen. So these are actually functions which are defined inside stdio.h header file. So this header file has declarations and where to look for these functions. So it's like you have got a new book, any book that you take, right? Um, so every book will have, say, a list of content here, and then it will also have some sort of references, like in the end of the lesson, it will have some references saying that refer this particular page for further information. So that is exactly what is happening here. So this is a reference to some other file. So that these things are called as headers. So if you want to use any function from a different file, so generally it is like it is put here and asking the compiler to refer this, because you cannot write entire program in one single file, right? You can write, of course, in theory you can write everything in one file, and you can just get things done, but that part is done by compiler. You don't have to worry about it. So what we need to worry about is human kind of thinking. So how do we separate the functionality? For example, if I want to write a program in C, which calculates sum, I know that a plus b in that statement will calculate the sum, but I want to do something more. So I want to take inputs from user. So that user input taking is done by scanf, and then you store the result in a variable. So I'll come to variables. I'm just telling you the patterns. So there are functions, there are variables, and you can call a function which you have defined above. This function is called here. So this is what is called as function. Function is a construct or a small set of instructions which can be like clubbed together and put it in a construct. That construct is called as function, and you can call as many times and as many places you want. So that is the advantage of a function. So I'm calling this function here. And finally, I'm printing like it is saying the sum of x is something like whatever your intent is, so and so, and it has a return statement. So this is the, like any given day, all the programming languages has these basic constructs. So let us go back to our terminal and understand how it how do we execute this and what is the process. So I'll just exit out of VI. So, whatever you're seeing, it's called as terminal. So it's like it's an interface to operating system. Like you can log in. So earlier days we didn't have UI, which is like Windows. You just switch on the computer and then get into the like you enter your name and password, and then windows are there. You can click and open any application, right? So it was not like that earlier. So we had the so when you start the computer, it would just give this blank screen, which is like terminal, and it is waiting for commands to execute. So if I want to say see all the files in a particular directory, so you have to remember these commands. You had to remember. So yeah, so now we have built windows around it, which is like UI, and you can click and see. So that is what is this terminal. Okay, that's a brief about terminal. So let me just okay. What we did just now is we executed some command, and just to translate what we learned. So we have the source code, which is sum.c, and let us see what these files mean. So these things are generated because we ran these commands. Command GCC is a compiler. Compiler is a program which will take the program that we have just written here, sum.c, and it will produce an output which is a.out. So that's what it is. So I'll show you the content of this. So cat paste. If you look at this, you remember there was just hash include, and then that is expanded to this. If you look at this, yeah, that is expanded to this code. which is generated by compiler, and it just brought in. It's like you have a reference in the book, and you are buying that reference book, and then you're putting it in your library. So that is what the headers mean. And then let us look at other files. And yeah, this is so we've learned about your text file, which is human readable, and then there is assembly level language, right? So forget about this for now. So all the machines does not produce this, but yeah, let's look at this sum.s. Sum.s. So you can see that this looks like assembly level language code, assembly code, which is nothing but, so the compiler that is installed on this particular computer, which is a MacBook, and which is using a M1 chip. Yeah, M1 chip, and then this program would look different uh, on your Intel chip or AMD chip or somewhere else. So this is assembly level code, which is specific for that particular chip. Okay, so there are you don't have to worry about these sections. So if you look at this instructions, so it has generated the assembly level instructions. So why is this needed? So compiler does stepwise. So what we saw in .i is like pre-compiling steps. So it looks at all the references and like bundles it and generates .i, and then it does generate assembly code, which is particular for that particular machine. You can also use some arguments. Yesterday I was talking about cross compilation, where you can compile this particular sum.c to an Intel machine. You can specify, I don't know the exact command, but you can find it online. You can say something like destination architecture, or something like Intel or whatever, x86 or whatever it is. Okay, you can, and that program won't be executable on your current machine if it's not Intel. You have to copy paste that and put that into other machine and get it executed, because your machine won't support the final output, which is the final output is some dot a dot out. There is also one output called as .o, which is nothing but an object code, which is almost like an executable, but it does not have, it is just one step before this. So you cannot actually, just like we did, we printed the sum.i, sum.c, and sum.s. They are text files. These are not text files. So there is a command to see what sort of file it is. So you can see that the object code of the program that we wrote is, it's saying this is Mac something 64-bit object, and it is also telling some ARM64, which is an architecture. So you can see the final file type of this a.out, which is almost similar, but it does not have, it is not an object file, but it is an executable. So you can read about what is the difference between object code and executable later, but these are the steps that any program would go through. So this is called as a compiled language. Why it is called as compiled languages is, we started with this first step, and then sum.i, which is like it sort of combined all the instructions into this, and this is step 2. And yeah, just ignore this for a while. We'll come. Yeah, you can read about this. So yeah, and then this is called as this is what we saw, the assembly level language here. So that is step 3. This is step 4, and finally this is step 5. Okay, so we generated a human readable source code. This is text file to finally executable. So this particular program cannot be executed on even on a MacBook which is running Intel chip, because MacBook has some different chips, right? So it supports its own chip, which is M1, M2, M3, M4, series, and then it also supports Intel chips. So this is specific for this. So just keep that in mind. So these languages are called as compiled languages. The thing that you're executing is the final a dot out. You can actually tell rename the file, but this is a final executable. And from some.c we got this. So this is called as compilation process. Okay. So we were talking about operating system yesterday. So, and then what languages like Java and Python does is, so there is also something called as an interpreted language. So what is it? So how it is different, but at chip level, it does not care because it does not know at all, because it is not aware of what sort of programming language is used to execute instructions on the chip. So let us talk about interpreted languages. So interpreted languages are like, for example, if you open any shell script and you write some commands and say ls, say cd and pwd or whatever. So if you don't know about these commands, don't worry, but these are just instructions. So if you just put this a list of commands in your shell script, which is say some t.sh, something like that, a text file. If you execute this, it will start executing from line number 1, which is ls, cd, and pwd. So this is like step by step. So your shell interprets line by line and then executes this command. So similarly, so what Java and Python like programming languages do is, so Java has so all this has compilation step, but it is not visible, or it is not you don't have to worry about the compilation process. So I was talking about the hardware yesterday, and then on top of hardware we have installed OS. So OS can be of different types. So for example, this particular laptop uses Mac OS, and you can use Linux and Windows. And yeah, so each of this has their own versions, like Mac has Safari and ABCD, and Linux has its own versions, flavors like Ubuntu and so on. Windows has its own versions like Windows 10, XP, whatever. So all these are different operating system, and then on top of the operating systems, there are applications running, which is like the applications that you're seeing on the screen. Okay. So these are all of these programs, including OS, is built like this, whatever we saw. So this is whatever we saw was like very primitive code, but you can actually look at like how does there is source code for Linux operating system and all this. You can look at that. Um, so now you can at least understand what are these constructs, right? And then the interpreted languages are what they're trying to do is, on top of OS, they also run an application here called as virtual machine. Don't confuse with the virtual machine which VMware produces, or the hypervisor have a virtual machine. This is just a program. When you install Java or Python, so if you are on Windows, you can see on the like bottom of your screen, I think on yeah, right. So you can open Task Manager and you can see like Java virtual machine running. So what these languages solve the problem is, you don't have to worry about OS, you don't have to worry about hardware. You can actually compile your code to something called as bytecode. And this bytecode can be like packaged or taken and put on any other machine. For example, if you have generated that particular bytecode on your MacBook, which is working here, and then it can be also like packaged or copy pasted to a Linux box or a Windows thing. So this is where your interoperability comes into picture. Interoperability. So what is the use case for if you imagine if you have say you are working in a team where you have a banking software which is written in Java, and uh, you have like large like source code, thousands of files and so on, and you have packaged that program, and it is running on your banking machines, like people who are on the banking machines, right? Like people who are collecting the money and giving you the information, clearing the check, and so on. So everybody is using your software, and it so happens that since world is always changing, there is a new technology. For example, uh, your chip is like there is a new version of chip. Probably they want to change the hardware in the data center, and they want to move to a new chip. So if there were no such translators, you would actually want to recompile all of this code again and generate the executable and deploy it to every machine. So instead, you can also have that Java virtual machine which is running. You just change that Java virtual machine, and your bytecode would work on that machine as well. So that is what is called as an interoperability. So given that you have to install the like new VM or VM on that new hardware as well, which is like on top of OS. Okay, so that is how the interpreted languages came into picture. Now Java, especially, it goes through two steps. One is called as, which is compilation. So it does not compile to a final object code as we saw in C. It gets compiled to something called as bytecode. And bytecode, that is why you have two commands like Java C, which will produce one file, and then you have some other files. So similarly, Python works similarly. So these languages are both compiled and interpreted languages. But for your understanding and your don't get confused if somebody asks how Python works, and you just say that it gets interpreted. So, or just keep that Python starts executing um, from the line one itself. But if you look at, if you go back to, I'll just clear all my drawings. If you look at the program here in C, which is sum.c, it our program won't start executing from line one. I will just show you here. So file.out, where is we got here. Yeah. So this is the line number one. Okay. So while executing, it does not execute from here, right? So we saw that this is the file which gets executed. So it has its own format. So the compiler looks at the beginning of the program, which is main. So every file or every C program will have one main. This is to tell the compiler that this is the entry point for the program. So from here, it goes here, printf, and it does not find the function here. So it goes back to this place. So it sort of make a note that, okay, printf is, sorry, not here, defined in stdio, and then scanf is defined here, and then it executes this and looks at this, and now it already knows that printf is available there. And then return statement is where you tell the CPU that exit out of this program. Okay, so that is this is the this is an instruction. This is the pattern. So you have main function for all the compiled languages, and you have some references which are called as headers, and you have functions, and there are like several functions. So this is just sum.c. So if you want to write a module for a calculator, you would have sum.c. You would have diff.c probably, which is difference, and you could have mul.c, and all of these programs could be bundled together and produce one executable, which is maybe called as calc.exe or calc.out, or however you want to name it. So Yeah. So this is how the programming works. So bytecode. Sorry. This is the difference between compilation process and interpretation process. Okay. So any questions here, you can stop me and ask. So feel free to ask. So yeah. So this is about compilation, and let us just now get back to Python. So I'll just open one. Uh, so this is how you invoke the interpreter. So if you just so on my laptop, so you can maybe just Python works on your machine. So in my laptop, I have not configured that system variables, so that's why I'm using Python 3. But yeah, it does not matter, Python or Python 3, whichever works for you. And you don't have to do anything on the terminal, but you have to understand this is how it works. So if you get into terminal, so this is where you can start writing the programs. So for example, I can say a is equal to 1, which is nothing but a is a variable. And then why it is called as a variable? Because I can override, I'll just print a, okay. And you can override a. So that is why it is called as a variable. So that is so why there are variables, why there are data types. I'll just explain. So a is 2, and then say I'll do b is equal to 2.8, something like this, and c is equal to something like. Okay. So you can see that I am in Python. We don't have to remember, or we don't have to specify what sort of variable it is. So if you don't have to remember, you can refer later. So if you look at the C program, you will have something like you'll have to define what sort of variable it is. So for example, if you had to do the same thing in C, you'd say something like int a is equal to 1. But in Python, you don't have to do this because Python is intelligent enough to look at this and internally translate that to integer. I'll show you how it looks like in Python. So a is equal to 1, and I have to tell in other languages like C, C++, Java, that what sort of variable it is. So why do we have this? So I'll just write B as well. So if you have to write it in C, it would be something like float B is equal to 2.8. And C would be something like, I think in C or C++, it would be something like char star C is equal to something like I. So yeah, don't worry about this star and all these things. So these are specific patterns that so that the compiler can recognize what sort of variable it is. Okay. So this is called as an string. So this is termed as string for like humans. String is nothing but sequence of characters. Characters are nothing but A, B, C, D, 1, 2, 3, all these characters that you see on the keyboard. So there are invisible characters as well. For example, written, which is the enter key on your laptop, right? That works, but you don't see it. Like if you have 10 new lines, you won't be able to tell how many lines are there, like because it's invisible, and space is an invisible character. So all of this count to characters. So that is why we say that character, and then we say that there is a sequence of characters, which is char star, and then we tell the compiler that whenever you see a variable called as C, interpret that as string. Okay. Whenever you see B, interpret that as 2.8, which is a float number. Float number is nothing but a decimal numbers for just for now. Okay. So why do we have all these constructs in the first place? So in order to understand one step back, we have this particular RAM and chip, right? So this is RAM, and so you should never forget that what is underlying things that is working. So that is what makes you a programmer. So once you see this, so we are telling the compiler that allocate. So RAM is nothing but memory space, right? So how RAM works is it has rows of memories, and it's something like you can imagine it, or you can interpret it like a grid. So each of this grid has got an address. Okay. So whenever I say a is equal to 1, I'm asking compiler, when you load this program, make sure that I get n number of bits. Bits are nothing but ones and zeros, right? So each of this is a bit. Yeah. So if you fill up all these grids with 0, it's just, yeah, these are bits. So 1 0 1 0 1 1, something like this. So 1 is nothing but, if you write it in binary language, right, by some binary way, it is 1. And where does this 1 go and sit on the RAM is, if you are using a 32-bit computer, so you'll have 31 zeros, and in the end you'll have 1. So we are trying to manipulate ones and zeros, like we are trying to generate ones and zeros and asking for the memory. So this is one of the use cases for why do we have data type. So we are asking for the memory. So it's like booking a seat in your college, in your school, or in a theater, something like that. So you book the seats and then say that, okay, there's a variable coming and sitting here, and the sizes of these are different. For example, in C, an integer takes about 4 bytes. Okay, why it is so? Because the largest number can be like really big. It's not just like 32 bits. It's it's 32 bits, which is like 8 into 4. So it will consume entire row. In the, say, if you think of it as a theater, it will consume entire row of that. So if you look at a float, probably it is even more, something like, let us assume that it's 64, and probably it would occupy 2 rows in that theater of a RAM, right? So this is why we specify what sort of data type it is, and then so on. So character has this. So high probably consumes 2 characters. Of course, it is consuming 2 characters, and each of the characters is 1 byte long, which is 1 byte is nothing but 8 bits. Okay, so in order to place 8 bits, you just need like half of, not half, like 1/4 of the rows, right? Because you have 32 rows on a 32-bit machine. Okay, so that is one of the reasons why we have these constructs. These are called as variable types or data types, we can call it. Yeah, I think, yeah. So this is data and its type. Okay, so, and another reason is, for example, you probably will do something like a plus b. Okay, when we do a plus b, just like in C program we did, it is possible that by mistake you might be sending one as one data type. For example, this as an integer, which is a number, and this as a char star, which is a string. Okay, and this operation is actually an invalid operation from a real world point of view. For example, my name is Digant, and I want to add Digant string with a number like Digant plus 10. It does not make any sense, right? So 10 plus 10, yes, it makes sense because both of them are numbers. 10 plus 10.1, it makes sense because both are numbers of different types, which is fine. And but strings and numbers don't go together. So one of the other advantage of having data types is compiler restricts and finds out that such operations should not be allowed. So what we can call restriction of operation or something like this. Okay. So one of the advantages of data types. So this is how the compiler looks at these instructions in higher level languages like C. But how does Python work internally? So Python works like this. So I'll just show you what it means. So automatically Python recognizes these data types looking at this particular input. So there is a function called as type in Python. Don't worry about this now, but just I want to show what it is. You can see that the type of this particular variable that we have just defined, we haven't specified whether it's an integer or anything, but it has interpreted that as an integer. So this is internal to Python interpreter. So it automatically interprets. So these languages are also called as dynamically typed languages. So C and C++, such languages are like typed languages, which is like you specify the variables what type it is, but in such languages it is called as like dynamically typed languages. So there are other languages such as well. I think JavaScript works in similar way. So not sure, you can check, but there are several other languages. So okay, so this is what is called as a variable and variables type. So if let me just show you other types as well. So this is a float. This is interpreted by default as float. And let us look at C. And okay, you can look that it is a string. Now let us try to add B plus C. You can see that the interpreter did not allow to add B plus C. B is a number, which is an float number, which is like a decimal, and high is a string. So it says that it is unsupported. It's not supported. So you're trying to add float and string. So that is why it stops you. So that is one of the reasons why these data types are defined at a program level where humans can write. But if you really look at the CPU, but CPU does not care. So even if there is a way to combine B and C, and then if you send it to CPU, it will just add it. It looks at the binary values and then it just adds it. So it does not matter. This is for like humans. Okay. So that is about the data type. Now in Python, there are different data types. So I can have now let us get so this is the interpreter. You don't have to worry about like opening this. You can open this and try out, but this is not the way we execute the program. So I just wanted to show like how it executes. You can execute line by line. For example, I defined a variable here and it got executed. Once I press the enter, that particular instruction gets executed. So let me quit out of this and let me write a simple program, something called as like, simple.py. So this is how we used to this is how if you don't have any IDE, this is how you write the program. Instead of VI, you can use Notepad, Notepad++, or any text editor. So I will write something like A is equal to same program which we wrote, and B is equal to say 2.8, and C is equal to some string which is hi, hello, something like this. And I'll try to execute it and I'll tell you some information about it. For example, so how do you just like we compiled and generated the dot out, which is we generated a dot out, which is an executable. We are trying to execute this program directly. This particular program, which is Python 3, has intelligence to take this particular executable and interpret line by line. So it has already done its job. It has interpreted line by line. We are not seeing anything on the monitor. That is because we are not printing anything. So monitor, if you look at monitor, it is a peripheral device in the sense that you actually don't require a monitor to work on or to execute a program. So only when you want to see what is happening inside, you have this monitor where you can plug in your monitor with that cable. Now we were using like cables which are like USB-C and so on, but we had like big cable where you can with a lot of pins and you can insert the monitor, right? So big monitor. So anything that you connect to the laptop isn't, it's a peripheral device. So keyboard, a mouse, touchpad, mic, everything is a peripheral device for any given computer. So uh, we have not invoked a function which writes onto these peripheral devices. So that is why we are not able to see it. So in order to see all these things, to get a visibility of what these variables contain, I'll have to use a function called as print, and I will have to print a there is a certain syntax, like you separate these variables with comma, and then you have these braces which are highlighted in like light green, bluish green, whatever it is, and you can execute it again. So now you can see that it has printed 1 2.8, and then we have this hi hello. So this is how we can see what is happening on using the print statement. Okay, so let us go back and execute. So I'll tell you one of the differences. So how virtual machine or the Python interpreter is getting the input, and what is the difference between the compiled languages. For example, we generated just a while ago a dot out. A dot out was generated out of some dot c, right? You can in fact tell that generate different name, but yeah. So it is in the program, if you remember, we had printf and scanf, so functions. So in the scanf is something where it invokes the peripheral device, which is the keyboard, and it is waiting for uh, input to be given um, by the keyboard. So it is saying enter two integers. I'm going to just enter two integers and press enter, and scanf started working. And let me just cat the sum.c. Okay, this was our program. Okay, and if you look at this, so here, so where did we get this from? This particular statement is from yeah, this, sorry, this printf. So this is the printf which prints something on the screen, okay, which is a peripheral device. So that these are the things that you have to remember. Like when you write a program, you have to remember that, okay, once you start executing a program, it is loading onto the RAM is taking like CPU is waiting for a certain space in RAM to like grab the instructions and execute it. So but this is for humans, so this is the place that it has stopped for scanning two numbers, and we have also specified the format that use space to enter two numbers. And soon after this, there was a function called, which is called as sum, which is nothing but this function. And so the lines that you're seeing, which is having two forward slashes, these are called comments in C. We have similar thing in Python. We will look at that, but you just look at the pattern. You don't have to worry about the program syntax and all these things. And you're printing something at the end, some of slash, sorry, percentage %d and d is so and so. So this is nothing but, where is this? Yeah, here. So these are the like um, things that we did in C, exactly what we are trying to do in Python as well. So I'll just go back to the Python program. So now you saw that it is not like sequential execution, because we yeah, don't worry about this command. So I have just printed the entire file with line numbers. Okay, so we started at line number 8 and we exited at line number 2022 in C program. But if you look at Python program, which is written simple.py, it start executing from line number 1. So if you closely look at the commands that we ran, we did not specify, like in Python, we are doing Python and giving that file name, right? We are not specifying this. We are directly executing the executable. Why are we executing directly here is because we have already generated executable, which can be run on this particular chip, which is Mac chip. And you can just say, tell this particular, yeah, somebody scribing. Yeah. So tell the computer that pick this file, which is an executable file, and load it to RAM directly. And this is done by the operating system, which has a connection with this particular shell. Shell is nothing but the terminal that you're seeing. So, but if you look at Python program, so I haven't executed the Python program. And where is it? So simple.py. Yeah, Python command for not found because I have not created the alias for this Python 3. So now it has printed. Our program was this. This was our program with line numbers. It has interpreted line by line, and then like it is printing here. So this is how the interpreted languages and compiled languages work. So this concept is important to keep in mind. Now, let us try to study the data types in Python. Like quickly, this is so the understanding of the concept takes explaining and understanding takes time. But to learn about the patterns, which is like data types in Python, it's quite simple. So now I hope you have understood why there is a data type, because we want to ask like number of seats in that theater, which is nothing but RAM. And we also have to put some constraints that addition or whatever operations should not be allowed on certain data type, just like strings and numbers addition or something like that. So let us get back to our editor, this is a VS Code editor, so which I have asked you to install. Now, so far we understood how things are generated, right? So now it is easy to understand data types in Python. So yeah, I'll share the notes why we have data types. I have just explained. So I have asked. So in this, this is called as Copilot in this editor. You can work with Cursor as well. Cursor does the same thing. Cursor is nothing but it's a clone of VS Code, and it has its own way to do things. But nowadays, so you get this particular section which is called as like chatbot. I just asked, I want to teach my students about Python data types, give me some snippets. So it has generated these snippets. Now let us try to understand this. So now we already explained that what is this. This is just a variable, and variable is type of integer. We are not specifying, it is Python interprets automatically. And then we looked at strings, and there is something else, something called as Boolean. Boolean is nothing but there are just two values, which is like true and false. So which can be like, you can store that in a variable. And there are something called as lists, and there is tuples and dictionaries and sets. So I'll just briefly talk about these data types. These data types are derived data types of whatever we have it here. Okay. So in fact, I think it's not a data type, it's a data structure. So basically, what is difference between data structure and data type is For example, if you want to represent, say, list of books or a library, so you have a lot of books. If you have one book, you can say that book one is equal to, say struck, yeah, uh, book is equal to, say, yeah, something like that. So it is auto completing. So this feature is readily available in the latest version. So you can see that it is just no, auto suggesting all these things. So see, I'm just typing, tab, and it is thinking that okay, you might need this, and it's generating. So it's not always that you want to pick this up. So I'm just picking this up. So you can see that this is an integer. This is this one. So what is a list? Is nothing but you can have the collection of, say, strings. For example, if you closely look at this, this is a list of books. So it's a collection which you can modify. For example, let us go. So how it is interpreting is looking at this square brackets. So anytime you do like list test, okay, and then you put some square braces, and this tells Python that there is some set of data coming on your way. So that set of data is 1, 2, 3, 4, 5. So which is nothing but like integer, 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 integer. So in fact, list, you can also have list of, okay, it's time up, but yeah, I'll take 5 minutes to cover all these things. So list of mixed. See, I haven't finished typing. It has already like suggested looking at this variable and just guessing what I might want. So this is what we wanted. So you can also put mixed data types, which is like in this particular bunch, which is a list. You have integer, you have string, you have a float. So that is what is list means. So these are, you can think of this as like containers. So what other containers are there? So one is list, and there is something called as I'll just show here, tuples. So the tuples or tuples, however you can call it. So you can generate this code, and there is something like here. You can insert at the cursor. You can just click on this, and it will insert here. So this is a variable coordinates. You can see that difference is in how Python knows it is not a list, but it is tuple or a tuple is looking at these braces. So if you have square braces, that is a list. If you have this, what is it called? Like round braces, maybe. Yeah, this braces, it is a tuple. So difference between tuple and list is that you cannot modify this tuple. So for example, let me get back here to our terminal just to show you. Python 3, you can say coordinates. I'll just use coordinates and equal to, and I'll just say 1 and 2. I'll just keep two numbers in the list. So if you look at the type of this CO, so it is a list. So I can go to CO, and if I want to access the first element, it is always with 0. So in programming, the first number that is there to catch hold of any container or any list of things is with 0. So these are also called as array in C. So this is how you can access that element. You can also change this to 3. Now if you print, or you can just say CO on interpreter, it will just print these numbers. You can see that 1 is changed to 3. So the difference between tuple and yeah. So let me try to change the first element. It tells that this item is not supported. Okay, so this is a read-only list. So that is what you can think of it as. Tuple is nothing but a read-only list. So what are the applications? For example, coordinates. So even by mistake during the course of your like writing the program, so maybe it is possible that some program would read and some code would change that value, right? So that should not happen. So I want to tell the interpreter that don't change this variable called as coordinates. So that is where this read only comes into picture. Okay. So that's about tuples. And let's talk about dictionaries. Dictionaries are nothing but like the general dictionary that we speak about, right? You have a key, which is nothing but like you have a word and its meaning. So word is unique. For example, if you take a word called like unique, so unique means if you open the dictionary and go to that place, you will see that unique means it does not repeat again, something like that. That's the meaning of the unique, right? So you have a key and a value. So that is what is called as dictionary. So how Python knows dictionary is defined? So this is how it knows. So it has a different sort of braces, which is a flower brace or a curly brace, whatever it's called. So you can see that there is a key and then there is a value. So in real world where it is used, for example, if you want to like just imagine, like if you go to say a train station and you have a lot of luggage and you go to a cloakroom, so where you keep your luggages and collect it later after your trip. So you go to cloakroom and then clockroom. So and then you keep your luggage. What you get is you get a ticket, right? You get a ticket or a number or something like that. So you get that token, you carry that token and come back and give that token. And from that token, that person knows that okay, this token is tied to that particular location. Maybe it's a like a whatever they keep in that rows, right? So he knows that where this particular number is tied to, and he goes and picks that and gives it to you. So that number is unique, right? So because you cannot have two tickets pointing to same luggage. So then two people will start fighting that it's my luggage. So that is where your dictionary comes into picture. To implement such systems, you need to have key and value. So this is one of the examples. Like name is this one, and for example, your email ID you can use it as a key because it's like unique, and you can use some other value as a like variables. So email is a key, and then that value will be like your email address, and then so on. Okay, so yeah, that is about a dictionary. We will see about this later. And you can also see there is something called as set. Set is nothing but it looks almost similar to dictionary, but it does not have values. So it's like data type with unique elements, just the keys. Okay, so where it is used, you can think of say you have an Excel sheet, and you have a lot of numbers in that Excel sheet in a certain row, and you want to like deduplicate them in the sense that you want to remove all the duplicates in that Excel sheet. So there is a function in Excel where you can right click and deduplicate or remove the duplicates, right? So similarly, you can probably we have got a list which has got like a lot of numbers, and I want just unique numbers. So I can convert that list into a set where it will remove all the duplicate numbers because it just holds the key. And so this data type means that there is no duplication. So this data type will make sure that even if you give uh, a new this one, right, new number, it won't add a new number. For example, let us try here. So I'll paste unique numbers. This is the set. So there is a function to add numbers. So if I print these unique numbers, there are like 4 elements. So let me try to add, which is already there, like, yeah, 4. So if you look at this, we still have like the old, like only 4 numbers. It did not add because it's already there. So if you try to add, so which is number which is not there, say 6, and you can see that it has got added. So this particular data type, make sure that there are no duplicates. So that is about sets. So, and then let us learn about, there is also something called as none type. It is, none type means, it's like, you can think of like an empty cell in Excel sheet. So it does not mean anything, but it's there, like it's a placeholder sort of a thing. So with if you have coming from languages like C, C++, it's null in ULL. So we can just, it points to a certain location in RAM that nobody can access. So it's just like that. You can, for if you're coming from non-programming background, just imagine that it's an empty space in the in an Excel sheet. Okay, so these are the data types. So it is important to understand why data types are there. And now we have learned about this. So tomorrow we can write a simple program with more programming constraints. We have learned about these 2 things. We can learn about these things tomorrow, and then put this together to write a program. So where your overall goal is to generate the program, I can say generate a program to what take input of names and age. Okay, you just have to do this, but once the output is coming out of this program, now you should be able to tell, okay, this is a variable, people is a variable, what is this, this is a flower braces, and it does not have anything. So maybe it is a dictionary, maybe it's a set, but I don't know. So this is how you need to interpret it. Maybe it's a dictionary. And then there is something called as input function. There is something is getting called and something is getting converted, and then there is a loop, and then there are variables here which are taking processing the output of these functions, and we are printing something, and so on. So once you have learned these constructs, you should be able to read the program, and if possible, you should be able to verify the programs. So that's all you need to be able to do. So you need to get your hands off the programming, but you need to ask the GPT saying that, okay, this is what I need, and this is what, and then you should be able to verify. So that is the place we should be in as a current world programmers. So you don't have to write all this. So I wrote all this just to explain why there are data types and what is compiled languages, what is dynamically typed languages, and so on. So once you know this, you know the difference, and you can look at any program and see the constructs. So you don't have to restrict to just Python. Okay, yeah. So that's all I had for today. Yeah.
Sir, you told tuple is like tuple, it is unchangeable. Can we do like add operation to that, or something like subtract? Or is it fully
Subtract
constant?
from what? To remove something, is it?
Yeah, yeah, to remove or to add something.
No, this is so you can let us ask. So I know the answer, but this is the exercise that I want you to do. Can tuple be changed? Okay, so I'll tell you how to find out what are the methods and things like that. So if you look at this, then yeah, it gives you no tuples are immutable and so on, so on. Okay, so yeah, tuples are immutable. Okay, which means we cannot do anything. So how do you, so for example, if you don't have this chatbot or internet, how do you find out that? Okay, so let's go back to the terminal. If you look at this is what was our tuple, and there is a function called as dir. You can, which is nothing but a function given any object data type into that, it will list out the operations that you can do on that particular data type. So if you look at this dir of CO, which has a lot of functions, which are operations that you can do on the on this particular data type, which is a tuple or tuple. So if you look at this, it does not have all this double underscore functions, right? These are not accessible to, like, you should not touch that. Okay, so if you look at the functions, which is like usable by programmers, there are only two functions, count and index. So, but if you just take, let me just say list and 2 and 3, I'm just creating a temporary list just to show the difference. If you look at this, you can see that there are functions which can be used to modify this particular data type. So if you are ever confused, you don't have to remember. So now we will remember, of course, but if you ever find okay, whether it's immutable, whether can I do these operations, ask your GPT, get used to that. If you don't have GPT, then find out like this, like these are the operations. So for any given object, so everything is an object in Python. Data type is an object. Your numbers are objects. Functions are objects. Files are objects. Everything is an object. So if you just do the dir, you can look at what are the functions available for me to operate on top of that. So for this, like what was that tuple? We don't have anything except the count and index. But in Python, you have, like, you can append a number and so on. For example, li append and append 3 list. You can see that we changed this list to this, which is like a modifiable data type. But in tuple, you cannot do that. Did I make your point here?
Yes, sir. Yes, sir.
Yeah, thanks. Yeah. So open your this one, the editor, and if you go here in your like right side bottom here, you see this icon. This is a Copilot icon. If you just click, it will open this chatbot, and we'll discuss about this. Like, there are different modes and all these things. But yeah, so try to make use of this and try to understand how it is working. And if you want to even go one step more, write a Python program, open the terminal here, which is nothing but the terminal that we saw here. It's the same thing, but it is embedded inside this editor. You can do the same thing. You can do Python 3, and then you can do simple dot py and then execute that. So this is how, without editor, you can like without the modern editors, this is how you execute the program. But there are ways. For example, like you can click on this button to like execute the program. Like this is run and so on. But yeah, but in real world, so this button won't be there, right? So somewhere you need to invoke it. So this is how it gets invoked. But you can try these programs in the sense that you ask what you want to ask is, okay, today I learned about data types. Give me some examples. Don't write your own programs, and try to be able to recognize these patterns. If you see the square brackets, it's list. If you see the this sort of braces, round braces, it's tuple. If you see flower braces, it could be dictionary or it could be set. Dictionary is nothing but it has two things, key and value. Set has just just the braces. Set dictionary does not allow duplicates, duplicate keys. Set does not allow duplicate elements at all. And you also have something called as Boolean, which is true or false. And then you have something called as none. So these are the data types. So with this, we can start doing a lot of things, which we'll see in further classes. Okay, that's it for today. Thanks for staying. Yeah, we overshot the time. Yeah, but yeah, thanks. Yeah. And feel free to ask any questions and reach out to me if you want to talk one-on-one. That's even better to do that. No worries.
Sir, is there any cheat sheet to remember like data types?
Don't all this era of cheat sheets and everything is gone. Use like install on your mobile, install ChatGPT, install Cloud, or install Perplexity. So you don't have to remember anything. So you just ask like, I want cheat sheet or something, like I want this concepts. It will generate the cheat sheet. But so if you ask me, I will do the same thing. But I want you guys to get used to these LLM models. LLM models are nothing but this ChatGPT, Perplexity, and whatever. So get used to that. So if you are used to that, so you just need to like be able to recognize the patterns. You don't have to like remember anything. So yeah, you just ask ChatGPT. Please install ChatGPT on your mobile phones and then start doing this.
Okay.
Yeah. Thanks. Yeah. Have a great day. Yeah. See you. Bye.